move to another African initiative from Libya this time, and Mr. Abdulmalek Baitulmal from the Libyan Organization for Quantum Technology in Tripoli in Libya, who will deliver another interesting talk called Quantum in Telecom, the Community and Workforce. To you, Abdulmalek.
Yes, yes. How are you?
Yeah, I'm doing well, and you?
Yeah, very good. Does it sound
Glad
very
to
clear?
have you between us. Yeah, thank you.
You can hear me clearly, right?
There is some noise actually in the background, but yeah, I can hear you well.
Okay, maybe if I could remove the headphones, just a second. Yeah, what about now?
Yeah, cool. Okay.
Okay, great. Uh, so let me just jump to sharing my screen. Okay. Yeah, so do you see the slides?
Yes, sir.
Sure. Okay. So is it in full screen, right?
Great. Yeah.
Okay, thanks. Thanks everybody. It was an interesting day so far. Just hearing the talks that are being given by Dr. Najwa and Farai. Uh, I'm not going to deeply go into community like too much, but I'm going to spin off my talk at the end to speak about that. So let me just tell you about myself. My name is Abdulmalek Baitulmal. I'm currently based here in Tripoli, Libya, where I studied telecommunications at the University of Tripoli. I've graduated not from too long, from a year and a half or so. So since I graduated, where I had my bachelor degree in simulating a Shor's algorithm, which led me to the fact that I need to do more in the local community here to bridge Libya from not having any types of quantum resources, quantum education in computer science and relating to quantum information science. But I had a lot of obstacles. I had a lot of barriers that I had to to get over. Eventually, I'm here, and once I have graduated, I've been working on co-founding a startup, Quanta LY, which is aiming. We're aiming to prepare the Libyan industries for the upcoming. What is yet to come from quantum technologies here in Africa and Libya, especially. So what you see in the background, I have joined remotely an incubation competition for about 8 months, which was organized by Bina Business Incubator, which is actually is placed in Turkey, but they're actually having they have another they recently have just opened an office here in Tripoli. So in general, at that time, at the same time, I was doing the business incubation competition. I had a great opportunity to join Huawei Telecommunication and Technologies company as a software engineering intern. So I had faced a very hard time trying to focus on both my responsibilities as a trainee and as well as bearing up with the incubation competition, which eventually led me to choose either Huawei company or my quantum career. And here I am today, sharing a space with great people like Dr. Najwa and Farai and all the great speakers. Uh, However, these this experience that I had on both in Huawei company, which was very hard for me to focus on, and also co-founding a company, joining the as this story. Let me just go back here. Joining the local builders of the communities of the entrepreneurs who are trying to develop new technological workforce here in Libya. So I had so much insight, a huge insight actually towards how can I really build or I can really establish some quantum services, quantum products in a company in a company which is based in a country that is lacking all types of education, all types of the types of the awareness, the know-how in the we're talking about the either the private or the governmental sectors. This was actually the point that Dr. Najwa was referring from just in a minute before I started my talk. I will share more about this about the experience that I had and how to and from my experience, like how to move forward with the quantum community at the end of the end of the talk. So let me just tell you about. Why are you here? So today, hopefully, I will try to cover up the telecommunication generations in brief and talk about the requirements of 5G technology and just to have an intuition of why quantum computing is needed and what are the proposed use cases in the next generations of telecom. And yeah, last but not least, we're going to discuss the future of the workforce spinning off the community. Yeah, so let's start with the telecom generations. So the first generation of telecommunications gave rise to modern mobile communications as we know it. The analog voice calls were first initiated. Then after that, the second generation of technologies were about the transition from analog signals to digital signals, like to having you can use text messages now. And right after that, the third generation of technologies further boosted the evolution from voice to data, where we were able to to browse and use the 3D technologies to browse internet, and that gave the opportunity to for applications to be used in smartphones and stuff. Uh, so after that, the 4G 4G evolution greatly improved the network bandwidth and throughput, and we started to see really fast mobile broadband. In some countries, 4G networks speeds are varying from let's say from about 50 megabits per second, and up to some countries have to up to 200 megabits per second. It relies on the telecom infrastructure actually. But interesting about 4G networks is it uses internet protocol, which means like each device on the network has an assigned IP address. This is actually was a huge opening for what's called the quality of service requirements. Like if I'm connected to the network, what is my current need? Do I do I use an app for streaming? Do I use just a normal app that is using for that I'm using for normal browsing? So the network needs to identify my needs, and then the network can provides you with here. You don't need really huge bandwidth. You just need just small amount of data. Here, some of the quota that you might require. Not a lot, just small of the network background. In some countries, the quality of service is not that well acquired in the infrastructure. However, moving on to 5G, now 5G networks give rise to supporting more industries, creating an end-to-end ecosystem while building a fully mobile, we're talking about fully connected society in the fourth industrial revolution. Talking about in details in 5G. So in order to achieve the overall vision of 5G and provide the services that cannot be implemented on 4G networks, the ITU, which is the International Telecommunication Union, has defined 3 application scenarios for 5G, which is based on the needs the needs of this decade. So the first is a throughput with the 10 gigabit per second speed. We're talking here about the applications of virtual reality, augmented reality, which need extreme mobile broadband connections. The second requirement is the 1 milliseconds ultra low latency. This is actually very crucial in automated driving. We're talking about drones, smart grids, remote surgery. So these applications, actually, the existing networks of 4G networks can be really reliable to meet the low latency requirements of such services. The third, requirement is the connection density of what it's called, which is having 1 million connections per square kilometer. Uh, to make this really, really understandable, we're going to consider the management and operations of smart cities. So a smart city uses information and communication technology to sense, to analyze, to integrate key information in the C operating systems. For example, in very traffic cities, and when the traffic requirements increase, far exceeding the capacity of some 3 tower cells, then the network management system basically just splits these 3 adjacent cells into maybe 4 cells or 5 cells, just to lower the capacity per each cell, which enhance the connections, or enhance the massive connections that would be applied in each site. So since 5G assures a new era of applications, such as, let's say, the autonomous driving networks, the AR, VR networks, IoT networks, these are different logical networks, which meaning that the logical network for those who are not familiar with the abbreviation is that logical networks, which means that you might have one network, but you can divide it into several logical networks. Some also consider it as or abbreviated as network slicing in general. So the network management is managing different network slices. As you can see here, the architecture of 5G network slices, each slice have different instances for the same slice, different applications. Thus, we can use slicing technology to meet the different requirements of thousands of applications on the network. This actually brings us to a very special topic, which is the cloudification of the architecture. This is actually where quantum gets in. So the 3GPP, which is responsible for the standardization in telecommunications, back in 2018 and 2017, actually has released the release 15 from the 3GPP. Actually, the radio network architecture splits the cloudification of networks into mainly 2 parts. The first is called the centralized unit, and the other is called the distributed unit. Uh, so to maybe talk about this in details, so this shows how the option of the upper layer that consists of the RRC, which is the radio resource control, and the PDCP, which is the packet data control protocol, which are hosted by the centralized unit. Mainly they involve slow processes. We're mentioning here about from 10 to 100 milliseconds processes. So these protocols or these processes, they don't require the huge requirement of a real-time processing. So this is defined as a RAN NRT, which is the radio network cloudification slash the non-real time. So the functions here can be cloudified. We'll talk about this in brief later, where quantum gets in. So the part below the PDCP layer from the RLC, which is the radio link control, these layers cannot be cloudified since there are real-time processes that requires a dedicated baseband devices. For those who are not familiar with baseband devices, you can just you may be familiar with the beam forming from the antennas that is you know up up on the roof of your building. We're also talking about the digital signal processing and using Fourier transform to do some forming in the signal processing in general. So as I said, we will see in a bit why this is important to consider for the quantum use cases. Yeah, so this is the quantum tech, where it comes into play. Like it's going to change the landscape of cloudification development in a whole another way. Considering the massive connectivity which requires ultimate secure channels, we were talking here, reducing the complexity in the network by using the parallelism properties within the quantum computation. And this is why it is proposed and expected for quantum to be a key changer in telecom. This talk is not really, I'm not really going really deep scientifically. I'm just going, in general, we're talking here, we're talking the use cases. Yeah, so let's take a look now on some of the partnerships development globally and what are the vendors are aiming for. So our first example here is what the South Korean Telecom, the SK Telecom and the ID Quantique are the first in bringing the security of benefits of the quantum random number generators to the masses of Samsung Galaxy A quantum smartphone. And I'm not sure a lot of you heard about that, but that made a huge deal back, I don't know, it was maybe less than a year ago, maybe. Um, so prior to that was applying the QRNG, the quantum random number generator, to the SK Telecom's 5G authentication center, which is actually just to enable the two-factor authentication for such services as single sign-in or the biometric authentication in payment services and so on. Let's move to the next one. Yeah, so for the quantum key distribution, we see a partnership between the Telefonica and Huawei company, which demonstrates the application of quantum cryptography on commercial optical networks. And they're actually, their operational integration by means of software-defined networking technologies. The software-defined network, or the SDN, has been abbreviated. You can consider it as a tool that allows you to control the parameters in the network just using a software tools. You know, you don't need to go out there and decide and change a lot of the hardware. This is actually where the telecom infrastructures are going. Is the software-defined networks are to be expected the future of telecommunications. So a huge development actually been done by a lot of research centers, a lot of telecom vendors in SDN. So last but not least, we have the efforts from Ericsson, which is actually one of the first adopters that are considering the research of quantum algorithms within several telecom infrastructures. So one of the main use cases is the physical layer and data processing. I don't know if you can see my pointer here, but yeah. The use case is that the physical layer and data processing, where the quantum Fourier transform can reduce the number of vectors in digital signal processing. This actually can be seen for some who are telecom is their major. You can further read about this in the OFDMA, which is the orthogonal frequency multiplexing axis, which is just having a lot of signals carried on one huge like carrier, but having small subcarriers, which means that maybe four, five, six frequencies hopping on one big frequency. This actually for the massive connection requirements requires a huge amount of processing. A lot of them out there are trying to produce new or to develop new algorithms, to develop new techniques, to make the power consumption much less than what is taken now in the current device that has been used in signal processing. There's also the HHL, which is the also known as the quantum linear solver. Some predict that it can also help with the prediction of the quality of user experience for video streaming. We can also investigate the Grover's algorithm is also expected to be applied in the management plane to provide some database researches and database searches and so on. So as you can see, some of these use cases can be on the cloud, which are some of the use cases concerning the non-real-time scenario, which we have talked about earlier. Other than that, the user plane applied algorithms cannot be cloudified, so you can the quantum processing would be just on the local or let's say the local infrastructure of the network and not on the cloud. So you can mainly consider this as two main processors, two main roles in quantum in telecom. Some responsibilities for quantum computing are on the cloud and others on the user data plane. So in general, for quantum in telecom, we're still in the early stage. All of the telecom vendors know that, but it's always good to know what are the use cases. Where can we invest quantum in telecom? So in general, some of the use cases that are really important to note here are what is known as the quantum-aided multi-user transmission. Some are talking about the channel estimation and detection, which is one of the huge topics that are actually been developing by AI methods. We're talking machine learning, deep neural networks, and all of that. Just a disclaimer that most of the 5G research is done by AI methods. I haven't done a really deep research in 5G. I mean, I'm talking scientifically, but most of the students back in my back when I was doing my bachelor degree, other students have been developing or working on algorithms, AI algorithms. We're talking using these tools in channel estimation and detection the user. Also to investigate the load balancing between two users, and which is called the joint routing. So yes, so it is like there's huge work needs to be developed and to develop and apply AI methods on the quantum hardware, before talking about using quantum in telecom. But it is still early to talk about this, but as it said, when is the right time to plant a tree? And the answer is 25 years ago. So it's never too early to just investigate like what are the use cases that we could really work on. So the most interesting topic for me at least, which is by raising the question, how can we transform the education towards building the workforce along with the ecosystem? From my own personal experience, trying to develop products and services, that can be useful for the Libyan industries. I mean, I have done some market testing to see the response of the enterprises, what are their needs, and reflect these opinions to see how can we close the gaps in the ecosystem. So let me just tell you that as as Dr. Najwa said, and let me point that out clearly because it's coming not something that I heard, it's something that I have personally experienced. The quantum know-how is the quantum know-how in the community is the most important key enabler to develop the tech communities in such a way that there must be innovation and entrepreneurship to bridge between academia and business, which is a huge problem that we are facing here in Africa. I say it's time to build I prefer to prefer it as the test bed environment for entrepreneurs in quantum here in Africa to try out their ideas and when to think about it, like how we can really transform the communities here in Africa, because I'm not talking about my Libyan experience, where the Libyan experience that I had reflects with more than 70 or 80% on most of the countries here in Africa. So I believe it's like, what's an experienced entrepreneur if it's not someone who tried too many times and had a lot of failures towards trying to find the right way to do business? And that actually raises a huge note that we really need to take out from this talk, is that this is a call for action. Thanks very much. I'm open to
Uh,
all types of questions.
okay, thank you, Abdulmalik, for this presentation. And yeah, and now back to the audience. If you have any question, please don't hesitate to leave your questions in the chat so we can read them.
Just keep sharing that, just to, if someone needs to connect with me in
Yeah,
LinkedIn, Twitter, or maybe email. I'm always open, just to.
definitely. We have a question actually from Murat Almini. Thank you, Abdulmalik. Can you say a few more words about the quantum community in Libya, academia, industry?
Yeah, so one of the big obstacles that I faced towards taking a quantum leap is that we're lacking a huge, like big time. We're lacking the quantum education here in Libya. I'm not talking about quantum mechanics. There are some good professors here actually taking some good roles about and giving some really good courses in quantum mechanics. But I'm talking about the quantum information science. There are up till now, like from my own understanding in the Libyan educational systems, there are no education in quantum information science in Libya, which actually this was the huge obstacle that I faced back when I was working. Like, I had a dream to work on quantum computing for my bachelor degree, but I had to go out there, like on the Twitter community, the LinkedIn community, and this is actually what brought me here today with you guys, like the awesome people gathering and just enabling others opportunities in quantum. From to take away to precisely answer Professor Murad, is that for now, as a keynote that I took from doing, trying to do a quantum business, is that do us like go back, like just small steps back, and focus on the community, build the know-how in the country, and actually quantum education would come eventually. Yeah, so I know there are any other questions.
Oh, yeah, actually, no more questions. I do believe, yeah. Okay. So, yeah, thank you again, Abdul Malik, for your presentation. And that was great to know that, there is some local initiative in Libya. And yeah, that was brilliant. Thank you very much.